the recording. All right, so back from the break with the Zoom. So as I was saying before, so we're just removing the brackets here by applying the distributive law. So we multiply what is inside by what is outside. So 3 times x multiplying distributively, we get 3x. And then we keep the sign that is in the bracket. Once this is a positive, we maintain whatever sign that we have in the bracket. So now we have 3 times, so we put back the sign, then we say 3 times y, we get 3y. And so after removing the bracket, this is the expression that we are left with. Now notice here that these terms are unlike terms. And because they're unlike terms, we really can't simplify them into a single term, right? So we leave the expression as it is. All right, so for the next one, where now we have number beside the term in the bracket, and we're multiplying by a number outside. So it is important to remember that you multiply the numbers together and then group back, just group back the x or the letters with them, right? So in this case, we would say 5 times 2 give you 10, and we just group back the x with it, right? So that gives you 10x. Now we keep the sign in the brackets. Now we say 5 times 3, we get 15, and group the y with it, then we get 15y. Here we would say now 4 times a, we get 4a. Maintain the sign in the bracket, just the same. And then now next we would say 4 times 2, we get 8. So we would get what? 8b. All right, so that's applying rule number 1. All right, continuing with rule number 1. So it shouldn't be difficult to see what is happening here. So m times a will give you what? ma. And in the case here where we have the results written in this form, nothing is wrong with it, the result, it is correct. However, the way how we would love for you to write it is to write the letters in alphabetical order. And so that would be a practice. So instead of writing MA, we would write AM because A comes before M. And instead of writing MB, we would also write BM as practice, right? So that's the way how we actually do it in math in terms of a convention. Convention is just a particular way that we adopt. You know, we either write something or produce an answer. All right, so with that said, so here now we have 3x times 2p. So we multiply the numbers together, 2, 3 is 6, and then we group the letters together. So that would be 6px. Now, maintaining the sign in the bracket, we have plus. Then now we say 3 times 3 give you 9, and then group the letters together. So that would be 9x cubed. Now, if you want to write this now in the alphabetic order, then you would know that the 6px would be okay. But for this one, with the 9, we would write that as what? We'd write this one as 9qx. So we just switch this around. All right. For this example 6 here, we have 4a times 2a. Multiply the numbers together. 4 2s 8. Now, once you're multiplying letters that are the same, then you have to raise to the power based on the number of A's that you have, all right? So outside you have A to the power 1, inside you have A to the power 1. A times A give you A squared. Now, next we maintain the sign, keep the plus sign, then we multiply 4A times B. So we have 4AB, all right? Any question about the sets of examples surrounding rule number 1? Any question? Let me see if you are okay with all that was done in this. All right. All right. So I guess everybody is following. All right. Moving on now to rule 2. Rule 2, where we say that if we have negative in front brackets, meaning that if you have a number which is negative, when you multiply what you have inside, whatever sign the numbers are on the inside, after you have multiplied out, these signs for the number inside will become opposite to what they are. Right? So the 2 in the bracket is positive, the 5 is negative, but when we multiply this out by the 3, negative 3, so negative 3 times positive 2 becomes negative 6x. So you notice that the term that was here being positive, the term that we multiply now becomes negative. Now, we don't want to just say maintain the sign in the bracket. What I want you to do is to do the multiplication first, and whatever sign you get, you put it here. So you now have negative 3 times negative 5. And if we are following the rule of multiplying by negatives, then we have negative times negative will give you positive. So now you will put the sign positive here. And then now the 3 times 5 will give you 15. And then you group back the y with it, all right? So that's pretty much rule number 2 at work. So let's just look at what we have here. So here now, when you just only have a negative sign by itself, now you have to now assume that the negative sign by itself is negative 1. And so if this is negative 1, then we can say negative 1 times m give you a negative m, because the m in the bracket is positive. So if you multiply it by a negative, it becomes negative. Now, negative 1 times positive n becomes negative n, right? So this is what you get after you would have multiplied what is in the bracket by what is outside. Here now, negative 1 again times p give you a negative p. Negative 1 now times negative q will now give you positive q. And here we have negative 2 times p give you negative 2p. And negative 2 times negative 3 give you positive 6, and you put back the q. All right, so everybody should be following so far. All right, so that was rule 2. Now we're on to rule 3. Now rule 3 says that whenever you're simplifying expressions, right, and you have a number of brackets within the expression, you first want to remove the brackets, then you add like terms together. Now remember, when we say simplifying, student, simplify may be used generally to mean make when you're simplifying, just make it simpler. That's what simplify really means. So it means whatever operation you need to carry out to make it simpler, then you do those operations. So in this case, to make what we have here simpler, we first need to remove the brackets, then we're going to add like terms together. Now for the first bracket, how do we remove the first bracket, students? Ms. Shea, would you like to tell me how we go about removing the first bracket? Not getting a response from Shea. So it appears as if she's either not there or she refused to respond. Miss Ashanti, for the first bracket, how can we remove the brackets here? Are you there, Miss Ashanti? Not getting any response. That's not good. Miss Brittany, Miss Cold Spring. Any suggestion? Let me see the answer.
Excuse me, sir.
Hold on a second.
You asked.
Hold on a second, Mr. Campbell. Just hold on. All right. So let me ask Miss Green. How can we remove the brackets for the first expression?
Sir, sir, I'm gonna pass, sir.
All right. Miss Waysome, how can we remove the first bracket? The bracket of the first expression?
Sir, we'll use 1 on the outside to multiply with whatever inside the bracket, sir. So when we see an expression with no number before it, sir, we automatically assume that there's an imaginary 1 in front of the bracket. So we use that 1 to multiply whatever is inside the bracket.
All right. Mr. Campbell, what was it that you were about to say?
I was asking a question because I was asking you if you did ask how to go ahead and solve the question. But, oh.
I'm not sure if I'm getting you clearly just now. So you're asking me if
you ask the class how you solve, how you go about solving the question.
No, I didn't ask for a solution. I gave what the procedure is supposed to be. So the procedure should be you remove brackets first, then you add or subtract like terms together, right? That is how we go about simplifying it. But then my question was, for this first expression, how do we go about removing the brackets? And so that was the question. But Miss Waysome now would have given the answer, because even though we may have an expression, a bracket, or a term, if you have a term or a letter by itself, we can take the coefficient, the number within front that letter to be 1, because legitimately, if we multiply 1 by anything, we get back the thing. So here we have 1 times x, you will get back x. So because of that, we can always use 1 as the coefficient of any unknown where you don't have any obvious number in front of them. So the same thing with brackets. You don't have any obvious number out here. What you're really doing is to use 1 to distribute. So 1 times 3x you will get back what? 3x. 1 times 7y, you will get back 7y. Now, you don't necessarily always have to show the one that you're doing here. You could automatically just delete the brackets and you still would have the correct answer. But to show practically what really happens in terms of the rule, what you're really doing is multiplying what is in the brackets distributively by 1. All right, so just to bear that in mind. Now, for the second bracket, Miss Brittany, what we do now to remove the second bracket? Are you there, Miss Brittany? All right, Miss Maywa. How we go about removing the second bracket?
Sir,
Yeah.
we're going to put back the takeaway sign
Don't put back the tick.
and put 4x plus 3y.
All right. All right. You need to think about what you say you would just do. So I'm going to ask somebody else to give me their view of what you have said. All right. Anybody is in agreement with Miss Maywa? Or should I say anybody who is in some disagreement with Miss Maywa? If you have a different idea than what Miss Maywa has.
So repeat the question.
Miss Maywa, just tell us what she would do in removing the brackets. She said that she would put the minus sign beside the 4x and then now write back the plus 3y. Is that what you say, Miss Maywa?
Yes, sir.
Right. So I was asking her to think about what she just said. So I'm asking if there is anybody with any different idea from what she just gave me.
Sir, is it that you're going to apply rule number 2, rule number 1 and 2 there?
I don't want you to be asked.
Sir.
I want you to be.
Sir, that's what we are going to do. Apply rule number 1 and 2.
All right, so apply it for me, miss, and tell me what we'll get.
So sir, rule number 1 says, sir, I can hardly see now misplace my glasses. I can't find my glasses. So it's kind of difficult to see on the screen.
Okay. All right, so you're not.
Sir. Sir, you're going to multiply everything in the bracket by 1 because 1 will be outside the bracket.
All right, then multiply the bracket by 1.
Yes, sir.
What do you have to say about it? Miss Clark, you have your hand up. What are you saying?
All right, sir. Once you have a negative outside the bracket, then everything on the signs on the inside of the bracket is gonna change. So negative basically -1 times 4x will give you a negative 4x, and then -1 times 3y give you a negative 3y.
All right. Anybody else is in agreement with Miss Clark? Was that what you were saying, Ms. Wilson?
No, sir, I didn't comment any at all on this one, so it wasn't me.
Oh,
But I do agree with Ms. Clark.
okay. All right. Now, so what you have to remember, guys, for this one, where there's no number or no sign, you use 1. But where there is only a negative sign, you now have to use -1. Right? Now, if you don't remember that you're using -1 there, as what Miss Clark would have said based on the sign in front of the bracket, once there's a negative sign in front of the bracket, what you have inside, you change the signs to their opposites. So the +4 becomes -4, and the +3y becomes -4y. So +4x becomes -4. So based on the rule that we say, if there is a negative sign in front of the brackets, then the sign of what you have in the brackets would change to their opposite when the bracket is removed, when the brackets are removed. All right, so pretty much, let me see the hands of those who understand what just happened here in terms of removing the brackets. All right. So now that we have removed the brackets, then our next step is to do what?
Group them, sir.
Group them what?
Group them according to X and Y.
What do we call according to here?
Like terms together.
All right, so we are grouping them based on like terms, and like terms will have the same letters with the same powers, right? Or if you don't want to say the same letters, you can call them variables. Or if you don't want to say variables, you can call them unknowns, right? So whichever one you refer to means the same thing. Letters, unknowns, variables. All right, so when we're adding terms, we try first to group like terms. And so when we add like terms together, what will happen is that it will simplify into a single term. Now, wherever we have unlike terms and we're trying to add those, then we will end up having an expression, because we cannot add unlike terms in the same way how we add like terms. I think we had started off on that when we just started looking at basic algebra. So here now, the like terms will be 3x and 4x, because those have the same unknowns. So we group them together, 3x minus 4x and then now we group 7y. So we put a plus sign for the 7y. So plus 7y minus 3y. So we group them for the ease at which we can calculate them when we group them. All right, so we group them to make it simpler for us to see what we're doing. So we're taking away 4x from 3x. So what are we going to be left with here? If you have 3x and you minus 4x, what is the answer?
-X, sir.
All right. So we're applying the same rule as we did when we were looking at directed numbers. And remember, we say that when we are simplifying algebraic terms, when you're simplifying like terms, you're simply just adding their coefficients. right? And the coefficients here have to do with the number in front, the unknowns. So for this first x, we have 3 as a number. The next one, we have -4. So all we need to do is to add the 3 and the -4, and then put back our x beside it. Now, you should have known by now, you're adding a positive and a negative number, you find the difference and keep the sign of the larger one. So we take away the smaller one from the larger one, 3 from 4, give you 1, and then you keep the sign. So this would be -1x. All right. Now, generally, we know that if you multiply x by -1, you're simply going to get -x. So oftentimes we just skip out this part. We don't say -1x. When you start referring to your unknown in terms of 1x or 1y or so on, it's a little bit mathematically naive to write one of a variable, because once you leave the variable by itself, it is understood that is one variable you have, right? So here we have -x. So clearly, instead of writing -1x, we could just write -x to mean that is only 1x that we have. All right. So now for the y's, we would take away the 3 from the 7, and 3 from 7 will give you what?
Four.
I guess nobody.
Negative.
What would you get? Positive or -4?
Positive. Positive 4.
So you will get +4 because the 7 has a bigger sign. You take away 3 from 7, and you keep the sign of the bigger one. The 3 from 7 give you 4. The 7 is the bigger one and it has positive. So your answer should be +4. So now we will have what? +4y. Now, this by itself now, we have 2 unknowns here. And once you have 2 unknowns, we can simplify them as the same as what I meant to say. Once you have 2 unlike terms, you can simplify them as the same as when you're simplifying like terms. If the terms are alike, we simplify them by just adding their coefficients. But when the terms are unlike, when you have unlike terms, we have to leave them as they are within the expression with the plus and minus sign between them, because the terms are different, so we cannot add them in the same way to say 4y minus x will give you a single term. It doesn't work like that, because here we don't know what y is and we don't know what x is. So we can take away x from y if they are not the same. All right. So here now we leave just as an expression when we have unlike terms. Now in this expression, however, we would have -x plus 4y. Now that would not be incorrect if you give me that answer. However, in practice, we want you to write the one that is positive first. So we have 4y and followed by the ones that are negative. So instead of write -x plus 4y, you should write 4y minus x. So it wouldn't be incorrect if you give this answer, but it's just that it looks a little bit awkward when you start an expression with a negative term. All right. So we rather that you write the negative, the positive first and the negative after. All right. Any question about that, guys? All right, let me see the hands of those who are good with this. Moving on. All right. So now, once we simplify this, our result going to be negative x plus 4. But as I say, you can write it as negative x plus 4y, but to write it in the more conventional form, we write positive 4y minus x. All right, so here we have another one here. I'm just going to give you about 2 minutes to remove the brackets from these and then simplify. Let's just see what answer you come up with. All right, so I'll give you 2 minutes to try that one. Whenever you feel like you arrive at the answer, you can just raise your hand and then you can walk me through what you did to arrive at your answer. All right, Ms. Wilson, you can go ahead. Tell us what to get.
All right, sir. For removing the first bracket, sir, we have 3 times 2x, which is 6x.
All right, so you get 6x.
Yes, sir. Plus 3 times 3y, give you 9y. Now the minus sign, so we have the minus and an imaginary one, so that is minus x. Minus 5y. So we then group like terms 6x minus x.
Just give me a second. Let me read. It looks too much like a key.
Yes, sir. Stop.
All right, go ahead now, Ms. Wilson.
Yes, sir. So we group like terms now. 6x minus x plus 9y minus 5y.
All right, so what you get from this?
Yes, sir. When we simplify, we get 5x plus 4y.
All right. Anybody else arrive at this answer? Let me see. All right, very good. All right, thanks much, Ms. Wilson. Very good. And so once you simplify this, we will get 5x plus 4y. All right, moving along. Here, we have another one. Now, if we are to remove the brackets here, we would multiply distributively by in the first bracket by x. So we get x times a give you ax plus x times b give you bx minus x times a give you minus ax and minus x times positive 3b give you minus 3bx. Now, grouping like terms together and simplifying, we would, and I hope everybody can appreciate here that even though we all have x's in all the terms, ax has to be grouped with ax and bx has to be grouped with bx. So for the ax, we take away ax from ax, and that gives you what? All right, so if you take away ax from ax, then you're going to be left with 0. And now you have bx minus 3bx, and then you're left with minus 2bx. Is that clear to everyone?
Yes, sir.
Okay, good. All right, here we have another one doing the same thing. Multiply out the brackets in a distributive fashion. We get 10a plus 6b plus 3a minus 6b. Grouping like terms together, adding and simplifying, we see that 10a plus 3a give you 13. However, we have 6b minus 6b, that's going to give you 0. So the answer remains at, our answer will remain 13a. So these would give you 0. All right, so in this one, 6b minus 6b give you 0. And likewise here, ax minus ax give you 0. So after you simplify this, you're left with that. After you simplify here, you're left with this. All right, I hope you guys are following. All right, moving on. Here you have some practice exercise. So I'm going to give you about, I don't think you should get more than about 5 minutes to finish those. And then once they're finished, just we're just going to work through them together. All right. So I'll give you 5 minutes, then we come back and then we work through them together. All right, guys.